Dear friends, welcome back to my video lecture series. In our today's lecture series, we are going to discuss how to solve the system of linear algebraic equations. I mean, solution of how to get the solution for system of simultaneous equations, particularly iterative way. Previously, we solved a direct way. That method is going to call Gauss elimination method. Now we are going to solve the same system of simultaneous equations using iterative way, iterative methods. Iterative methods, already I explained in the previous video lecture itself. Iterative methods, we are having two methods. It will be Gauss Jacobi and the Gauss Seidel. These are the two methods we are having in iterative. Now come to the problem. Consider the system of simultaneous equation a1x b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2. Similarly, the other equation. There are three system of equations are there. Now, as I told you already, iterative method we are having two concepts in your syllabus. One is Gauss Jacobi, another one is Gauss Seidel. Right. If you want to apply iterative method for this system of equation, it has to satisfy the diagonally dominant condition. What is diagonally dominant? These are the diagonal elements you know. So if you want to say the system of equation satisfying the diagonally dominant condition, the modular value of a1, that one should be greater than the sum of the rest of the elements, mod b1 plus modulus of c1. Similarly, from the second system of equation, it should be modular value of b2 should be greater than, well, we compare the sum of the rest of the two elements, modular value for that, a2 plus modulus c2. Then similarly from the last equation, it will be c3, the diagonal values we have to take. That's why we are going to call it as diagonally dominant. c3 should be greater than modulus of a3 plus modulus of b3. Then if it is satisfying the condition, what I can do from this equation is I can find x value. How to find x? Take all other elements to the right hand side. It will be d1 minus b1y minus c1z divided by a1. That a1 is the coefficient that will come from the, if it is satisfying the diagonally dominant condition, from the first one find the x value. I mean, write the first equation in terms of x, second equation in terms of y, and the third equation in terms of z. This is what we are going to do here. This is the important thing. If you want to use iterative methods to solve the system of equations, it has to satisfy the diagonally dominant condition. Look at that. This one only they mentioned here. First element should be greater than, from the first row, first element should be greater than the modular value of the rest of the elements. Similarly, second row, the second column of the diagonal element should be greater than the rest of some of the other modulo elements. Similarly, in the third one, the diagonal element should be greater than the other two elements, modular value of the other two elements. If it is satisfying, then we can apply the Gauss Jacobi and the Gauss Seidel methods. Clear? Right. Now, if it is satisfying the condition, as I told you already, from the first equation, I can write x in terms of everything. Keep only x left hand side, take other elements to the right hand side. Similarly, from the second equation, I can write y one side, in terms of y we are going to write. From the third, I can write z in terms of all the values. Only z you have to keep in the left hand side, take all other elements to the right hand side. That's it. Now some hints are there. It will help you to answer for some MCQ questions. Iteration method is self-correcting method. Because why it's going to call self-correcting? Suppose while I'm doing the iterative process, in any one of the iteration Please, I'm doing some mistake. So the result won't be wrong. In the upcoming iteration, automatically it will correct. That in the subsequent iteration, automatically it will correct the value. That's why it's going to call self-correcting method. So iteration method is going to call self-correcting method. Right. So when I have to stop the iteration, you know very well, we discussed the power method and other iterative process also. So where we have to stop until get the repeated value. The value is repeating, we can stop the iterative process. Here also we are going to do the same. The x, y, z start repeating with record degree of accuracy. Not only x, all the three. Sometime x will repeat, y and z it will repeat later. So until that you have to continue. So all the three elements should repeat until you have to continue the iterative process. Gauss Jacobi. There are some assumption we are going to made to to get the solution of system of simultaneous equation. In the first method, Gauss Jacobi, the initial assumption x equal to 0, y equal to 0, z equal to 0. In some other book, they will write like that as x power 0, y power 0, z power 0 equal to 0. So initially, we are going to consider 0, 0, 0. That's what the meaning here. Similarly, we have uh, an assumption in Gauss Seidel method also. That assumption is any y value 0, z value 0. It's not mandatory to give y1, y1 0, z1 0. Any two element we can take x0, y0, or y0, z0, or x0, z0. Any two elements you can give here. You can give initially, you can take that as 0. Uh, for uniformity, most of the people will solve like that: y equal to 0, z equal to 0. Then only you can easily get the cyclic or that correct order. So it's better to assume for the Gauss Seidel method, it's better to assume any two values as 0, particularly y I and z 0. I'm going to take here. What about for Gauss Jacobi? All the values x0, y0, z0 initially we are going to consider, right? What is the advantage? We are going to study Gauss Jacobi and the Gauss Seidel also. What is the advantage in Gauss Seidel and the Gauss Jacobi? If you want to compare the two methods, Gauss Seidel's in Gauss Seidel method, the convergence is so faster. So what will be roughly two times than Gauss Jacobi method. So Gauss Seidel method in Gauss Seidel method, which is faster, convergence will be faster, right? That is the best method while we compare Gauss Jacobi and the Gauss Seidel, right? I have taken examples for a better understanding of Gauss Jacobi as well as Gauss Seidel method. Now we are going to discuss how we can apply Gauss Jacobi method to solve the system of equations. System of simultaneous equations. So look at the three equations are there. Already in the direct method, we used a row reduction concept to solve, the Gauss elimination method we have applied in the direct method. There we applied a row reduction to do that. But here it's not like that. Gauss Jacobi and Gauss Seidel both are iterative method. So iterative method, first you have to check whether it is satisfying the diagonally dominant condition or not. Correct? So in the first row, modulo value of 10 should be greater than modulo value of minus 5. So modulus means again you will get plus 5 only, plus modulo value of minus 2. Similarly, from the second row, modulo value of minus 10, the diagonal element should be greater than the rest of the other two. So it's satisfying. From the third element, modulo 10 is greater than, here all are getting 10, 10, 10. It's not necessary. In some other problems, the system of equation, the coefficient will be vary. Right. Here modulo 1 plus modulo 6. So all are satisfying the condition, the diagonally dominant condition. So we can use Gauss Jacobi method. This is what I have given in this slide. So this is the given system of equation. Now we have to check whether it's satisfying the diagonal dominant condition or not. Yeah, this is what already I have written in the previous slide. So it's satisfying. It's greater than only. Here also, it is greater than the sum of these two. It is greater than the sum of the rest of the two elements. So I can apply Gauss Jacobi method. So I will tell you how to apply Gauss Jacobi method now. In your textbook, if you see that they solve, they will take the two initial values, and to get the next iteration, they applied it. It's look like a paragraph, but I'm not going to give like that. Uh, my presentation is going to be a different one. Before that, I would like to say something. So if it is satisfying the diagonal dominant condition from the first equation, I can write x. From the second equation, I can write y. From the third equation, I can write z. Let's write it. So I'm writing x, y, z. That's it. Now, as I told you already, I'm not going to give like a paragraph level what they have given in some other books. I'm going to give easiest formation like it's nothing but table formation. So if you are solving with the table formation, it will be very easy to understand. Right. Now come to the problem. This is first column iteration I'm going to take. Second column x value, that x equivalent to 3 plus 5y plus 2z divided by 10. Similarly, write y in other column, z in other column. Right. So now what is the initial assumption we have to take for Gauss Jacobi method? It will be x also 0, y also 0, and z also 0. Initially, we are going to assume like x0, y0, z0. This 0 it is, you can write 0 here, or initial iteration. Initial iteration. You can write like that also. Instead of, if you're getting confusion why we are writing 0. 0 means 0 iteration, initial iteration. Okay, don't confuse it. Right. Now, first iteration I have to find. So, what are the values I have to take? I have to find my x now. What are the values I have to take? Y value 0 and z value as 0. Old values we have to take. So just keep in mind that clue I'm going to give now. If you want to apply the Gauss Jacobi method, you have to take old values. Here, you have to take old values. What is old values? I have to solve. I have to find this one, this value now. This value now. So which values I have to take? Old values means the previous iteration values. That is what old values. For Gauss Seidel, I will take recent values, new values or recent values, whatever available there. I will tell you later, no need to confuse now. So I have to take old values. So I have to find my x equivalent to, I have to find, so which value? This equation only have to choose now. Give y value as 0, z value as 0. So 3 divided by 10, it will be 0.333. Now I have to find y value. What are the values I have to take? X is 0, I have to give, and what will be z also 0, I have to give. We are finding by x value, old value, and old iteration value, z value, old value. If I'm substituting, then I will get 0.0.3000. Here important thing is they may ask to fix two decimal places, 4 decimal or 3 decimal like that. Accordingly, you can choose your calculator. Fix mode will be there. You can fix accordingly. Right here, I fixed up to 4 decimal places. Right now, come to Z. If you want to find a Z, X value I want, X value old value, Y value I need. So old value only you have to take. So 0 0 if you are giving in the place x and y place, I can get this answer. Right. Now come to the second iteration. Second iteration, I have to proceed in the similar way. I have to find my x. Which value I have to take? If you want to move with the second iteration, you have to take the values from the first iteration, that is the old iteration, old values, as I told you already, old values. So if you want to find x, take y, so I have to substitute y value and the z value. What is y value? It is 3, and the z value, it is, sorry, not 3, 0.3, and z value minus 0.3. If I are giving both here, you can get this answer. So you no need to enter again by one, uh, again and again here. You can use the calculator. You can insert this formula in your calculator. I will tell you how to do that. So I will make separate video for that. You just go through that. Alpha. This symbol will be this pink color. It will be in the pink color. So you know very well, yellow colors the letters if you want to use, you will press the shift button. Now the pink color letters will be there. If you want to use the pink color letters, you have to press alpha. So what you have to do to insert this formula, press alpha x, alpha equivalent to pink color equivalent will be there, not a bigger equivalent to. Again, open your brace, 3 plus 5 y, I have to give pink color y, pink color letter will be there, alpha. So for that we have to press alpha. Alpha y plus 2 alpha m, z won't be there in the calculator. You can use some other f, a b c d e f, x y z will be there. Sorry, z won't be there, so you can use some other letter m instead of z. Instead of z, you can use what? M here. So divided by what will be 10. You can insert the formula like this. If you after that, if you press calculate button, CALC, this button, what will happen there is it will ask what is y value. In your display, it will be like that. So what you have to give? So you have to type 0.3 and press bigger equivalent to symbol. Then it will ask what is z value. Give minus 0.3. You should type it and press a bigger equivalent to. Automatically, this value will come. Automatically, that y value will come. I mean, while you are solving for y, it will ask what is the value of x and what is the value of z. Clear? Right. So this is the way you have to insert the formula. You practice with the calculator. I will post separate video how to insert the formula and how to do the cross check everything. What are the shortcuts available in our in your calculator? Everything I will make a separate video. Make use of it. Right. Now I have to find y value. Substitute x z. X is old value 0.3. Z is minus 0.3. Now I have to find my z. So substitute old value of x, old iteration value of x, old iteration value of y. I can get. Similarly, I have to continue the iteration process, both iteration. So when I can stop, you know very well. So I have to stop this process. The value, the x value should repeat, and y value should repeat, and the z value should repeat. If it is repeating at a certain level, I can stop in that place, at that place. So that value should be the final answer. So now it's not repeating. That's why I'm continuing the process. And the next one also, fifth iteration. If you want to find x value, take from the old iteration, fourth iteration values from this value. From fourth iteration, we have to take values. So similarly for y and c. Sixth iteration, for sixth iteration, which value you have to take? I have to find my x. So old value of y, old value of z, old iteration value of y and z. You will get this. Similarly for y, similarly for z, and continue the iterative process until you get the repeated values. Is it repeating? Not repeating. Seventh iteration also not repeating. Eighth also not repeating. And ninth, yeah, it's going to repeat, I think. So once 1716, its difference is going to decrease, right? 0.2851, next is 0.5053. 10th iteration, 0.3416. Yeah, look at that. It's repeated. Here also it is repeated. Sometime x first repeated, and then we have to continue the process for y and z. Here it's repeated. So the values are repeated. Therefore, x equal to 0.3416, y equivalent to 0.2851, and z equivalent to minus 0.5053. This will be the answer. How to do the cross check? Guys, listen one more thing. Here we are finding the approximate value. So how to do the cross check? You know very well the original system of equation a1x plus b1y plus c1z plus d1, sorry, equal to d1. Similarly, a2x, if you are giving this value in your calculator, solving for three unknowns, directly you can get the answer x, y, z. That will be exact. What you are finding in your calculator, that will be exact. What we are finding numerical way, Jacobi and Seidel, it is approximate. That is nearer to the exact value only. Clear? So this is the way to do the cross check. That value, little bit variation will be there. So more variation, if it is there, only solving, doing the cross check with the help of a calculator, we should check the table once again. That's it. So this is the way to use Gauss Jacobi method. That's it. X value is this 0.3416, Y value is 0.2851, and Z value is minus 0.5053. That's it. That's it, guys. This is the way to use Gauss Jacobi method. Now, the same problem I am going to take with the Gauss Seidel method. Then only you will come to know what are the advantages and the disadvantages, or what are the merits are there when you compare the two methods. Right. Now, as I told you already, in Gauss Seidel method, for Gauss Seidel method also, you have to check the diagonal dominant condition for the given system of equation. After that, you have to write from the first equation, you should write x in terms of everything. From the second equation, y in terms of everything. From the third equation, z in terms of everything. Right. Now, initially, what will take here? Look at that. X, there is nothing. Y is 0, Z is 0. I am taking like that. Y is 0, Z 0. X is nothing. So now, in the first iteration, I have to find the X value. So what are the values I have to take? Y and Z. I say here 2 is Z, guys. It is 2 is Z. Should be here. Am I right? Check the previous one. Previous slides. Yeah, it is 2 is Z. Okay. It is 2 is Z. Do not do the mistake. It is 2 is Z. Right. Now, what are the values I have to substitute? So for x, if you want to find x, I have to give y value is 0, and the 2 is z value is 0. I have to give. So these are all the yeah, as I told you already, Gauss Jacobi old values. For this one, new values are recent values. Clear? New values are recent values. We have to substitute to get the next iteration value. Now come to the point. We have to find y value. What are the values we have to give? New value of x, new value of z. So new value of z is not there. Only this one is the new value of z. But new value of x is there. This x value we have to substitute here. But what we will do in Gauss Jacobi? All old values only we will take to find the next iteration. If we want to find the second iteration, all first iteration only value only I will take. But what about here? In Gauss Seidel, if I want to find y value, what I will do? Recent value of x. Look at that. Now only just before only I found recent value of x and the recent value of z. Okay, fine. Now come to z. What is the value? X and y we have to take. What I will do in Gauss Jacobi, I will take old values of x and the old values of y only. But what about now? Recent values we have to take. New values or recent values. This x value, this y value we have to take to find z. Now come to the next iteration, second iteration. Tell me it is 2z. Don't forget it. Typo error. Right. So now I have to find x. Which y and z I can apply? Obviously, this is reason y, this is the reason z. There is no other reason value. So these two values we have to apply to get this. Now come to y. Y value, to find y, what are the values I have to apply? X value, z value. What is the reason x? Is it there? Yeah, it is here. Reason x and the recent z. These two values you have to take to apply this. But what we will do in Gauss Jacobi, this x and this z only we will take. In Gauss Jacobi, old iteration values we will take. In Gauss Seidel, what it should be? New iteration values or the recent iteration values we will take. That is the major difference here. That's it. Now, if you want to find z, for Gauss Jacobi, we will apply this old x and y. But it's not the case here. In Gauss Seidel, we have to take these are all the recent values of x and y. These recent values only we have to take. So continue the iteration, whether it check whether it is repeating or not. In the third iteration, it's not repeating. Fourth iteration, yeah, here also it is not repeating. Fifth iteration, to find x, it's not repeating. To find y, again to find y, what are the values I have to take? Recent value of x, recent value of z I have to take. Look at that, x and z I have to substitute. Recent x and the recent z, or new x, new z, right? So Gauss Seidel means recent value. Gauss Jacobi means old values. That's it, guys. If you use that clue, you won't do any mistakes while you're solving your problem, right? Yeah. Look at that, guys. As I told you already, no, it has been repeated. Z values are repeated here, but what about x and y? It is not repeated. So once if it is repeated, confirmly again you will get the same answer only. It won't be vary. Clear? That's why no need to bother. We should continue the process until get all the values are repeated. Here also it's not repeating. Even y values also not repeating here, not repeating. Yeah, as I told you already, no. Once it is repeated, I will get the repeated values only. It won't be changed. Now come to the seventh one. Yes, yeah, it is repeating 315, 315. Here also it's repeating. Already it has been repeated. So what will be? X value will be this. This is the final value of x. This is the final value of y. This is the final value of z. Where we get the answer in the Gauss Jacobi? Would you remember in the previous slide? In the 10th iteration. 10th iteration, we obtain the answer in Gauss Jacobi. But what about in Gauss Seidel? We are getting in the 7th iteration itself. So convergence is faster in Gauss Seidel when we compare Gauss Jacobi method. That's it. X values this, Y values this, and Z value this. Finally, you have to write your answer like that. That's it, guys. These are all the concepts you are having in Gauss Jacobi and Gauss Seidel. Finally, I would like to repeat it again. In Gauss Jacobi, you have to take old values. In Gauss Seidel, you have to take recent values or new values to find the next iteration value. This is the important thing. If you